Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to wrap up relations and functions. Yesterday we talked about relations, and hopefully we now really understand what relations mean. And we also talked a little bit about functions. We're going to get a little bit further into it today. A relation is any set of ordered pairs. You can write a relation in 4 different ways. You can write it as ordered pairs, as a mapping diagram, as a table of x and y values, or you can graph it. Okay? It's a relation. We also learned the basics of what a function was. A function, if you remember, is any relation where you can only have one y value for any given x value. So on a table, if you see when x is 1, the y is 5, and then you see later when x is 1, y is 6, that is not a function. You can only have one y for any one particular x value. We also learned about the vertical line test. And the vertical line test, basically what's happening is you're drawing a line through an x value. And you're trying to see how many times does that line hit the graph that I was given. If it hits it more than one time, that means that there are different y's, more than one y for the same x, and therefore it is not a function. Today, guys, we're going to go a little bit deeper into functions. We're going to be determining whether a relation expressed as an equation represents a function. Okay? When a relation is expressed as an equation, my brothers, you must verify that there is only not on, but one y value output for any given x value. Wow, what's going on with me today? Input. My bad. No excuses. I apologize. So let's do that clearly. You must verify that there is only one y value, the output, for any given x value, the input. Simply test one x value, and if it renders 2 or more different solutions for that same x value, then it is not a function. Okay? For example, what is this crazy man talking about? Go ahead and let's choose any x value you want for a. What x value do you want to choose? 2. Okay. So y equals negative 3 times 2 plus 2. So when x is 2, y equals negative 4. That's never going to change, guys, because in that particular equation, when x is 2, y is negative 4, period. That is a function, because when I plugged in one particular x value, I was given one particular y value, and that's a function done. Now, let's see how this works for b. Let's use 2 again. If I choose 2 for x, y equals plus or minus 8 this time. Do I have 2 different y's for the same x here? Yeah. When I plug in the value of 2 for x, I can have positive 8 or negative 8. So this is not a function. No, it's not a function. Yes, sir. That is plus or minus, because it has 2 roots. It has a positive root and a negative root, sir. So that came from a square root. When you're solving, for example, let's say you have y equals square root of 9. Y really equals positive 3 and negative 3. It's a plus or minus. It has a positive root and a negative root. So in this particular situation, this plus or minus, you have 2 different y's. Yes, sir, my brother.
I don't understand why you got a B.
Okay. Okay. No worries at all. Thank you. Maybe I went too fast. X, we're going to choose as 2. So if I plug in 2 for x, my brother, I'm getting y equals plus or minus 4 times 2, which is plus or minus 8. So I have 2 different y values for one x value. Bless you, by the way. So that is not a function. Yes, sir. Yes, sir. I'm sorry. I'm sorry. No, you can choose any x you want. Remember what we talked about for x? It's a very good question, son. Thank you so much. X can be anything it wants because it's independent, guys. When you go to a store Okay? You can buy 0 things or you can buy 3 things. Right? Okay? Right? When you're out and you want, I don't know, you want to go to the beach. You can choose to be at the beach for 1 hour, or, as long as your parents let you, you can choose to be there 12 hours. It's independent. So X is always independent. You choose what you like, sir. How about this bad boy? What X do you want to choose for this?
6.
Okay, 6. When X equals 6. Y equals 6 squared minus 3 times 6, gentlemen. So Y equals 36 minus 18. So when X is 6, gentlemen, Y is 18 and only 18. And this is a function, yes. How about this next one here? What do you want to choose for X? 4, okay. So 9 equals 4 squared plus Y squared. Subtract 16 to both sides because 4 squared is, 16. So I've got negative 7 equals Y squared. I'm going to take the square root of that. Y equals plus or minus the square root. Come on, moral. Oh, yeah, I'm right. Y equals the square root of plus or minus the square root of negative 7, which that's an imaginary number. We'll get there eventually. But what's happening here? Don't I have 2 different answers? Don't I have 2 different Y's for the same X? So this would be no, not a function. Okay? I'm going to give you a little hint here. Yes, sir. Correct. If you have Y equals plus or minus 2 different answers, it cannot be a function. Absolutely not. Because in this case, what's happening if I had a table here, okay, when X is 4, Y could be positive square root of negative 7. But according to this, when X is 4, it could be negative square root of 7 as well. Negative square root of negative 7. Can you have 2 different Y's for the same X? Does that make sense, my brother? Does that make sense? All of my brothers. Promise. Okay. May I continue? Okay. Real quick, though, I do want to give you a little hint. If Y is squared, it's never a function. Ever. 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 Yes, sir, my brother.
So on a test or a quiz, we can just like.
Yeah, if on a test or a quiz, guys, I tell you, is this a function? You could just say no right off the bat because you know that if Y is squared, you're going to have to square root the answer. And when you square root an answer, you're going to get a plus or minus answer. So you're going to have 2 different Y's for the same X. Thank you, my brother. Does that make sense, gentlemen? We're good? All righty. May I continue? Thank you. Okay, a lot of things to remember here. And if you notice, I say please on all of them. This is your choice, though, guys. These are things that you must remember. So please remember that a function is a relation where there is only one Y value for any given X value. Etch that into your brains, into your memory banks. Live it, love it, and learn it. A function can only have one Y value for any given X value. Remember, it doesn't work the other way, though. You can have different X's for the same Y, but you cannot have different Y's for the same X. You feel me? And just in case you're lying, look, you can have this. If Y is 2, 2, 2, 2, 2, and I go 1, 2, 3, 4, 5, this is a function. That is a function. You can, C-A-N, you can have different X's for the same Y. What you cannot have is this. 3, 3, 3, 1, 2, 3. This is not a function. This is not. You can only have one Y for any given X in a function. You feel me? Okay. Please remember that the x values are known as the independent variable, the input, and the domain. Please remember that the y values are known as the dependent, it depends on x, the output, it's the answer once you plug x in, and it's also known as the range. Please remember that a function represents a specific equation. A function represents a specific equation, okay, that do not alter, they do not change. For example, movie tickets cost $12 per person. So a function can be written for this situation since it is constant. You know that when you go buy the movie, you just see the gentleman or the lady working there. They just hit the number of tickets, correct? I promise you, there's a function, a code that's written into that computer already, into that cash register. And when they hit the number 5, it knows that, hey, I'm plugging in the X. And then it gives you a total. That's the Y. All right? So why don't we go ahead and call Y the total cost? Since Y is dependent. The total cost depends on how many tickets you buy. It is dependent on the number of tickets you purchase. We will call X independent since you can buy as many tickets as you like. Therefore, what do you think the function, the equation would be for this? Yes, sir. Very awesome. Y equals 12x, my brothers. So that means that every time that you go to the movie theater and you buy, let's say, 4 tickets, you see the cash register, the operator of the cash register, male or female, hit a 4. What the cash register is doing is saying y equals 12 times 4. Then it spits out the price that you have to pay. It's more complicated than that, of course, but in a simple function like this, that's what's going on. And again, this already includes tax usually, this price. Sometimes you have a more complicated function where you have to get the cost and then you have to add the tax. But in a nutshell, this is what a function represents. Okay? At McDonald's, okay, I don't know the real cost, but let's say the number 3 combination meal is, I don't know, $6.75, okay? I hope you've seen it. They'll hit the number of that combination, correct? The function for that combination would be 675 times x, where x is the number of those combo meals that you purchase. Does that make sense, brothers? Promise? All right, my brothers. May I continue? Word. All right. Determine if the equation or function for each table or situation. I want to determine, not if it is a function, it is a function. I want to determine the actual function. Okay. There's a little bit of an easier way to do this when we learn slope, but right now I'm going to have you use some logic. I need you to think a little bit. When we want to write a function, remember that the function has to apply to every single value in this table. It has to work for everything. So this is what I do. What did I do, or what are the possible things that I could have done to x to get y? Come again? Okay, you could have subtracted by 3. So let's see if that works. Y equals x minus 3. What's 1 minus 3? Works. What's 2 minus 3? What's 3 minus 3? Works. What's 4 minus 3? Works. That's my function. If someone else thought, well, what about multiply by negative 2? Okay, let's test it. Y equals negative 2x. When x is 1, it equals negative 2. It works. But when x is 2, 2 times negative 2 is not negative 1. That does not work. You had a question, my brother. No, you don't do it from the y because you're manipulating the x. The y is the output. The x is what you manipulate, add or subtract or multiply or divide to get that y. Thank you for asking, sir. How about for B? Yes, sir? No, you'd have to have all the values in order for you to test it to see if it worked. Thank you, son. Yes. Okay. For B, what did I do to y to x to get to y? Well, they're saying you multiply by 3. Let's see if it works. 1 times 3 is? 2 times 3 is? 3 times 3 is? 4 times 3 is? And there it is. Yes, sir. Yeah, it is a trial and error for now. There are skills later that we'll learn. We could write the equation in a few seconds, but we got to walk before we run. Thank you, sir, for caring and asking. Okay, how about this one? How would I write this function? The gym you join costs $30 per month plus a one-time fee of $250. Yes, sir. Fan-friggin-tastic. Very proud of you. Where X is what, my brother? Very good. The number of months. Get used to labeling things, guys. It really helps you out. And what would Y be, my man? The monthly cost. Well, actually, no. The total cost. Yeah, because depending on how many months you buy. So yeah, total cost. Very good. Does that make sense, gentlemen? Yeah? Okay. How about for B, ABC cell phones charge $20 per month for unlimited usage of the phone? Yes, sir. Yeah, Y equals 20X. Very good. Where X is the number of months and Y is the the cost. Does that make sense, gentlemen? You with me here? Any questions on this so far? Yes, sir, my brother. Yes, sir, the one of the gym. Yes, sir. You would only have to pay $250 once, but let's say that I plan on being there 100 months. You gotta calculate that into your cost. Okay, let's be realistic. I want to do it for 10 months. Okay, so how much is this really going to cost me? It's going to cost me 30 times every month 10 plus the 250 I had to pay. So that's 300 plus 250. That's $550 that it's going to cost me for 10 months. The 250 is a one-time fee. That's why I'm not multiplying the 250 times any variable. It's called a constant. That stays the same. Whether I'm going to be there 1 month or 1,000 months, I pay that 250 one time, but it's part of my total cost. Thank you. Sir? Negative 3 plus, okay, you could have put negative 3 plus x. However, I'm sure you guys, I hope you guys remember, linear equations are in the form of y equals mx plus b. You always want to get used to putting the x values with the highest exponent first. It's called standard form. So technically you could have put negative 3 plus x. I don't suggest it or recommend it. Always put the variables first and put the number, which is also called a constant, at the end always. Thank you, son. Great questions, guys. Anything else on this, my brothers? Okay. Identify the independent and dependent variable in each situation. In the winter, more electricity is used when the temperature goes down, and less is used when the temperature goes up. Which would be my independent variable here, and which would be my dependent variable here? Think about what affects what. Yes, sir. Yes, sir. Independent is the temperature. And what's the dependent, my man? The electricity used. Very good. Because the electricity used depends on the temperature. You guys know how it is. We live here in Miami. All right? When it gets really hot, I got to crank that AC. I'm going to spend a lot more money in the summer months here than I am in the winter months. The winter months, we get lucky and it's 70 degrees outside. Oh, it's nice in the house. You may not need to put on the AC. But in the summer months, we're going to have to put on that AC. Same thing in winter. Okay? In the winter, let's say you're up north, like in Chicago, you're going to use a lot more electricity in the winter because the temperatures are going to go down. So the more the temperature goes down, the more you have to turn up the heat. You're going to use more electricity. How about B? The cost of shipping a package is based on its weight. Yes, sir, my brother.
weight is independent.
Very good, son. The weight is independent. I can send, you know, um, a 1 ounce little letter to someone, or I can send a 15-pound care package to someone that's in Afghanistan. Okay? And then what would dependent be, my brother? That's exactly right. Very good, son. Very good. How about C? The faster Mike walks, the quicker he gets home. Yes, sir.
It is the time he walks, or no, the speed he walks.
Very good, son. The independent in this case is the speed, believe it or not. And then the dependent is the time it takes. Because in this case, he can't choose the time. The time it takes depends on his speed. Does that make sense? How about for D, a company charges $10 per hour to rent a jackhammer? Yes, sir, my brother.
The independence of hours.
Very good. Independence number of hours. And the dependent is the total cost. Fantastic. Beautiful. Nicely done, sir. Yes, sir.
The dependent be how much they need it for.
Come again?
Why can't the dependent be how much they need it for? How many hours they need jackhammer for?
No, because independent is the number of hours they need it for. I may need it for 1 hour or for 10 hours. The total cost depends on how many hours I rent it for. It's $10 per hour. Every hour is $10. So independent is the number of hours. Okay, I can do this job in 3 hours. I need it for 3 hours. That's independent. Okay, this is the first time I've ever done this job. I don't even know how to use a jackhammer. I'm going to have to learn how to use it. I may need it for 10 hours. The number of hours that you need it for is independent. You may be a professional with a jackhammer and you can do the job in half an hour. I may never have seen a jackhammer. It takes me 5. Okay? The total cost depends on how many hours you use it for, sir. Yes, sir. Oh, okay. What's this one then, my brother? Independent is the number of pounds. Very good. The number of pounds you buy.
Is the cost.
And the dependent is the total cost. Very good. I buy 10 pounds. It's going to cost you $9.90. You buy 1 pound, it costs you 99 cents. The cost depends on how many pounds you purchased. Does that make sense, gentlemen? All right. May I continue? All right. Let's wrap this up. Last but not least, guys, a function rule. A function rule is an equation that represents an output value y in terms of an input value x. You can write a function rule in what's called function notation. Shown below are examples of function rules. You got y equals 3x plus 2. Okay? This y can be rewritten as what's called f of x. F of x and y are the same thing. F of x is just a fancy way to call y. Now, if I tell you, find f of 1, look at what's happening. What did I replace my x value with here? So what do you think I'm going to replace every x with in the function? A 1. And this is how we evaluate functions using function notation. Okay? F of x is just a fancy way of writing y. Does that make sense? Sure? Okay. Now, find each of these. I want to find f of negative 3. What did I replace the x with here? So, f of negative 3 will equal negative 2 times negative 3 because I replaced the x with negative 3 plus 5. That's 6 plus 5, which is 11. F of negative 3 is 11. F of 1/4. Well, this equals negative 2 times 1/4 plus 5. This is going to equal negative 1/2 plus 5. Negative 1/2 plus 5 is 4.5. F of 0, I replace the x with a 0. So this will equal negative 2 times 0 plus 5. Negative 2 times 0 is 0 plus 5 is 5. Now what if I amped it up a little bit and I said to you, I want to find f of x minus 1. What am I replacing the x with here? So check this one out. This is going to be negative 4 times x minus 1 squared plus 1. Does that make sense? Okay, you shook your head. No, why? What did I replace the x with? X minus 1. So I plugged it into where my x is. Now, does that make sense? What if I said f of x plus f of minus 2? Well, this is going to be f of x, which is negative 4x squared plus 1, plus f of negative 2, which is negative 4 times 2 squared plus 1. So this would be negative 4x squared plus 1 minus 16 plus 1, which would equal negative 4x squared. 1 plus 1 is 2 minus 16 is negative 14. Yes, sir, my brother. What do you mean this square? 2 squared, I plugged x. 2 is x, so 2 squared is 4. 4 times 4 is 16. Negative 16 plus 2 is negative 14. For this one, f of 0 plus f of x plus 3. F of 0 is going to be negative 4 times 0 plus 1 plus f of x plus 3. Negative 4 times x plus 3 squared plus 1. So this would equal, that cancels, that's 1 minus 4 times x plus 3 squared plus 1. 1 plus 1 is 2, so this would be negative 4 times x plus 3 squared plus 2. Later on, we'll learn how to calculate this part, but for right now, I just want you to understand and realize that when you have an f of x, and that x changes to a number or an expression, you're going to plug that number or expression into every single x value of the function. Now listen up real quick, guys. I know you want to go to lunch. I've got this left, which I will do on my own right now. Please watch the video. Homework is valid. Have a great day. Thank you. Bye-bye. Okay, guys. So, ticket to a concert are available online for $35 each plus a handling fee of $250. The total cost of a function of the number of tickets bought. What function rule models the cost of the concert tickets? Evaluate the function for 4 tickets. Well, f of x, remember f of x is the same thing as y. So f of x equals $35 each, $35 for each ticket x plus a $250 handling fee. That's the function. I want to find the value of this function, the cost, when x is 4. So I'm replacing the x with 4, so I replace the x with 4 in the function, and I have 140 plus 250, so f of 4 equals $142.50. Okay? Number 8. You are buying bottles of a sports drink for a softball team. Each bottle costs $1.19. What function rule models the total cost of the purchase? Evaluate the function for 15 bottles. Well, f of x, the function, equals $1.19 for every bottle of sports drink x. So I want to find the cost when x, the number of bottles, is 15. So I replace the x with 15, which means that I replace the x of the function with 15, and $1.19 times 15 bottles, the cost of 15 bottles equals $17.85. And last but not least, in 2002, the Prestige oil tanker sank and started leaking oil off the coast of Spain. The oil slick took the shape of a circle. Suppose that the area A in square miles of the circle contaminated with oil can be determined using the function A of t equals 0.25 pi t squared, where t represents the number of days since the tanker sprang the leak. Identify the dependent and independent variables here. Well, the independent variable here, the independent is the t, right? Which equals the number of days. That's what's independent. The dependent here equals the area of the spill. And the area of the spill is the A of t. Evaluate A of 30. So I want to know the area of the spill when t, the number of days, is 30. Well, I'm going to have 0.25 times pi times 30 squared. This is 0.25 pi times 30 squared is 900. And 900 times 0.25 equals 225 pi. Okay? Pi, of course, is 3.14. So 225 times 3.14. The area of the spill after 30 days would be 706.5 square miles. And hopefully that makes sense. Thank you so very much once again. I wish you a great day and even better weekend. Hope you learned a lot, and I'll talk to you later. Bye-bye.